Hello and welcome back. In this video we'll be looking at starting section 4.1, which is on graphing the sine and cosine. And one important thing to note is that most of the time when we graph sine and cosine, we graph it in terms of radians and not in terms of degrees. The graphs would look the same, but just a lot stretched out if we did this in terms of degrees. So by working in radians, things will look a little bit nicer and things will go a bit smoother. And we should remember the conversion between degrees and radians. There are 180 degrees in pi radians, and this is our conversion. So if we want to if we want to turn degrees into radians, we have to divide by 180 to cancel out the degrees, and then multiply by pi. And this is because if I divide both sides by 180, we get pi over 180. So this is our conversion factor. So let's start converting some of these guys. So 0 degrees, well, that's just 0 radians. And 180 degrees, we said that was pi radians. But also 90 degrees, which is half of 180, should be a half of pi. And then let's do a few more. So if we just think about this in terms of multiplying by pi over 180, 30 times, so if I just do this calculation off to the side, 30 times pi over 180, well, 30 goes into 186 times, so that is going to be pi divided by 6. And for a few more of these, I'll just fill these in. 45 degrees is pi divided by 4. 60 degrees is pi divided by 3. 270 degrees, well, that's 180 degrees plus 90 degrees. So pi plus pi halves, that's 3 halves of pi. And 360, well, that's 280 degrees added together, so 2 pi radians is going to be 360. So then we have the sine of all these guys, and these are values that we have calculated before, so I'll simply fill these in. The sine at 0 is always going to be 0, and I want to fill in the quadrantal angles first. So by the time we reach 90 degrees, the sine has reached 1. When we reach 180 degrees, we've come back down to 0. At 270 degrees, we're back down to -1. And by 360, well, 360 degrees is the same as 0 degrees, so we're back to 0. And then for the sine, we have a few special angles, 30 degree angles, 45 degree angles, 60 degree angles. And for sine, the sine of a 30 degree angle is pi over 2. And the sine of a 60 degree angle is going to be the square root of 3 over 2. So these are two that we just have to remember. And for a 45 degree angle, we have the square root of 2 over 2. And then for cosine, these values are a little bit mixed up, but for the cosine, we'll start at 1. At 90 degree, we fall down to 0. 180, we're all the way down to -1. By 270, we're back up to 0. And by 360, we're back to where we started at 0. So we're back to 1. And then for a 30 degree angle, for a 45 degree angle, and for a 60 degree angle, we can see that these values are essentially flipped over. Notice that 30 and 60 are complementary angles, and they add up to 90 degrees. Sine and cosine are cofunctions, so the sine of 60 is equal to the cosine of 30. And there is a bunch of ways that we had to remember these. So let's actually graph these guys. So at 0 radians, sine is 0. So let's do the sine function up here. We've got not sine of x, sine of theta. So at 0, sine is 0. And then what I'm going to do is I'm going to put the quadrantal angles as my my bars on my y-axis. So I'll have so 1/2 pi to pi to 3/2 pi to 2 pi, 5 halves pi, and then 6 pi. And we'll start to see a pattern here. So sine at 0 is 0. Sine at 90 degrees is 1. Sine of pi is going to be 0. Sine of 3/2 pi is going to be -1. Sine of 2 pi is going to be 0. And this pattern repeats. We come up, we come down, down again, up. So we have this nice wave going on here. And if we were to plot these values in between, we'll see that as we cross the x-axis, we're going, more or less up, and then we'll flatten out, and then we come down, and then we flatten out, and then we come back up. I'm not the best at freehanding sine functions, but hopefully you can see the picture. So the idea is that we have this sort of wave going on. This is called a sinusoidal wave because this is a sine function. This is what the sine function looks like. The cosine function looks very similar, but at 0, the cosine is in fact going to be 1. Cosine this function will be 1, and then it starts this pattern again. It goes down to 0 at pi halves, down to -1, then up to 0, up to 1. So down to 0, down to -1, up to 0, back up to 1. And we have this same sort of pattern going on. But notice that we start at 1 here. So I'm not drawing very well today. Oh well. We'll just pretend like it's a nice smooth function. There will be pictures of this in the e-textbook as well. So we can see that we have the same sort of sine function here. It goes up to 1 and down to -1, just like our sine function. But the cosine function just happens to start at 1. So it's as if we took the sine function and shifted it over just a little bit, and then it would match. It would match exactly. So again, we've got pi over 2, pi, 3/2 pi, 2 pi. Over here we'd have 3 pi. Oh, I wrote 6 pi up here. I apologize. So we have our sine function. We've got our cosine function, and these are what they look like. So let's define a few terms that we can use to describe these guys. So the period is going to be the length of what's called a cycle, which is the repeating pattern. So when we look at the cosine, we can see that we've got a hump that comes over the x-axis, and then a hump that comes, and then a dip that comes below. And then we start the pattern over again. We have the hump, and then we'll go into a dip, and then we'll have a hump, and we'll go into a dip. So we can see that what I have highlighted in red is one period of the sine function. And we can see that its length is going to be 2 pi. This is 2 pi long. And so every 2 pi that we go over, we will have seen the same thing, the hump, then the dip, then the hump, then the dip. So for the sine function, so the period of sine is going to be 2 pi. And the same thing happens for the cosine. So if we start at 0, for instance, we see that we're at the top of this of this wave, the top of the crest, and then we come down, and now we're in the trough, and then we come back up, and we see that we hit the crest of the next wave. Oops. Exactly 2 pi from where we started from. And then again, no matter how far we go over, if we start at 2 pi and then we come up, if we go over 2 pi, we're at the top of the next wave. Come over 2 pi, we're at the top of the next wave. So this wavelength is also 2 pi. So the period of both the sine function and the cosine function is 2 pi. The amplitude is going to be the height of the wave, and this is a little bit tricky. So I want to be very, very careful. It's half the distance from the top to the bottom. So when we look at the sine function and we look to see, let me erase these boxes here. When we look at the height of the sine function, it gets as tall as 1. So this is the amplitude. However, when we look at the entire sine function, we go all the way from 1, so we bounce back and forth between being as tall as 1 or being as low as -1. So the amplitude is the distance from the center to the top of the wave, and that is going to be 1. So the distance from the center to the top of the wave is going to be the same as the distance from the center to the bottom of the wave, because it's symmetric. So if we go out 1 up, we're going to come 1 down. So the sine function has an amplitude of 1, but so does the cosine. We can see that from the distance from the center up to the top is going to be 1, and then the distance from the center down to the bottom, if this was drawn correctly, would also be 1, the distance from the center of the wave down. So the amplitude of sine and cosine is equal to 1. They just go up and down by 1. The domain, the values that we can plug into the function. So what values can we plug into a sine function? Well, you could take any degree angle that you want and plug it in. There's no restriction. I could plug in a 1000 pi radian angle. I could plug in a -1000 radian angle. I could plug in any value that I want into these guys. These functions will never stop going. So the domain of sine and cosine are both equal to the interval from 0 to infinity. This just means any number between 0, or sorry, I misspoke. The interval from -infinity to infinity. And this means that any number between -infinity and infinity, which is just every number, we can plug into the sine and cosine. And that's so that means that we can plug any value that we want into these functions. The range are the values that are the outputs of the function. So for instance, with the sine function, if I plug in 0, I get 0. So 0 is in the range. If I plug in pi halves, I get 1. So that means 1 is in the range. I can also get -1 if I plug in 3 halves pi. So I can get anything from 0 up to 1 and all the way down to -1. So the range of this function is going to be anything between 1 and -1. The same thing with the cosine. What are all of the values, what are all the outputs of this function? Well, it could be as high as 1 or as low as -1, and we can get every value in between. So the range of sine and cosine are both equal to -1 to 1. The reason I use square brackets is because we can get -1 and 1, whereas before we can't get negative infinity and infinity.